It's audio to the stream again, is what the problem is.
Check. Check test. 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 Check test.
Is there a sensor?
Yeah, but it's a nephliometer.
What?
That deals with
Uh-oh,
That's what you need to do.
there it goes. Wow, it went to the end. Hold on. Okay. Go. Not that I'm aware of. Well, we got this thing here. Let's see what it does. Woo. Shouldn't have done, man, I shouldn't have done that.
Well, that's what the case is solid.
Oh, that's a laser pointer. I don't think I should have done that. Let's see. Oh, there it is. Okay, left and right, Aaron. So there's right, there's left. So please use the microphone because we got like 200 people online, so it's, you gotta be able to hear them. Be this one right here. I'll give it to you.
Yeah, and they can adjust the curvature.
Yeah, and this thing, left and right. Don't top. Oh, yeah, there's something else. We're gonna use, hold on. We gotta use this screen pointer because otherwise people online can't see anything. Yeah. Yeah, wait a minute. Pointer, there's online, need to be able to see the pointer. See this thing here? So the mouse pointer is what we're gonna use. Fake laser, yes. Okay, it's 7:30 and we're gonna get started. Welcome to the May meeting of the Johnson Space Center Astronomical Society. Get started. Okay, so before we begin, if there's anyone here that's new, we'd like for you to raise your hand, tell us your name, Tell us how you found out about the JSC Astronomical Society and what your interest is in astronomy. Stephen. Microphone. Oh, yeah, and got talking to a microphone because we're online too.
My name is Steven, and I found out about this on Meetup. And my interest in astronomy is, I've always been fascinated by it, and there's always new things to learn.
Glad you're here. All right, over there. B, you got a mic?
Hi, I'm Lizzie, and my dad, he made me come tonight. Oh, I'm joking. No, I wanted to come. And he just bought us tickets to see Guardians of the Galaxy tomorrow, so I thought I would come. But no, I've always loved astronomy through him because of his love for it as well. So I thought I would come.
Excellent. Nice to see you. Anybody else? Is your first time here? Who here?
Hi, my name is Kim. I actually found out about the club through Google. I was just kind of searching around to see if there was anything like this in the area. I've always just been interested in astronomy and space and everything like that. So I just want to come check it out.
Excellent. Who's your buddy?
My name is John. She found it. I'm here with her. Space is cool.
Oh, that's all we need to know. Space is cool. All right. Anybody else? This is your first time here? This fella right over here?
Hello, everybody. I'm Pietro, originally from Italy, now also citizen of the US, and my curriculum is all about space. I work at JC, so I really deeply love astronomy, and I have a lot of telescopes at home. It's my first time. I just found you online. I hope that I can have a lot of fun with you guys. Thank you.
Excellent. You came to the right place. Anybody else? First time here? Or that's willing to admit it's your first time here? Oh, wait, way over here. Let's see, I bet his name is
Jerry Anderson,
Jerry. Knew it.
longtime NASA type person from 25 years here. Reed invited me tonight, and I've always been interested.
Excellent. You know, Reed went with us to the X-Bar Ranch last month. He's one of the brave 5 that went, yes. We did survive. We're still here. Anybody else? First time here? Let me know. Okay, I think that's it. Excellent. Okay, here's our agenda for this evening. First up, we're going to have Aaron Cohen. Dr. Aaron Cohen is going to give us Mysteries of the Universe, our main speaker. Then we're going to follow up with Ron's going to tell us about the DVD library. Then we'll have a short break. After the break, we'll have a couple members minute. The first one is me. I will tell you about Wind X-Bar and RR Lyra stars. And then Austin Meredith. Is Austin here? I hope he shows up because he's one of our speakers. Austin is going to be next with a members minute. Tell us about the UHCL Physics and Astronomy Club. Then Aaron Thero will be telling us about the Cosmic Campground that's in New Mexico, right? Yeah, pretty cool. He went out there. He's going to tell us about that. Then Francesco Fusco is going to be telling us about the United Space School. And then David will wrap it up with Star Party news. So first I thought I didn't have enough stuff for this meeting. Now I've got plenty of things. All right. If you don't get our JSCAS emails, there's 2 ways you can get them. You can just take a picture if you want to get these email addresses. The top one, you send an email to Ron, and that will get you just meetings only. The bottom email address will go to David, and that will get you on the general distribution list. It has meetings and other things. Or if you don't have a phone with you or can't copy those down fast enough, out on the table, there's a clipboard with a bunch of tear-offs that have these same 2 email addresses on them. So you can tear one of those off. But if you'd like to get on our distribution list, we'd love to have you on our email distribution. Or if you signed up in the past and you're not getting emails, try it again. Okay, green button blues. If that door is locked when you try to leave here, don't just press through the door. There's a green button to the right side of the door. You need to press the button, and the door's not supposed to be open for more than 20 seconds, but that will unlock the door and let you out of the building. Sometimes it's locked and sometimes it's not. Also, please don't go beyond the rotunda. That's our agreement. The restrooms are right out here to the right outside the door, but don't go beyond the rotunda down into the rest of the building. Reminder to presenters. We got a lot of presenters tonight, so everybody pay attention. You got to use a microphone. You can either use this one or you can use this one if you want walk around. For the pointer, don't use the green laser pointer. You use the mouse pointer here so the people online can see what you're pointing at. And if you're in the audience and you want to ask a question, wait till B or Trevor get to you with a microphone so that the people online can hear your question. Thank you. Fire alarm. Okay, so first up, we have Dr. Aaron Clevenson. And Aaron always has very interesting presentations, so I know this is going to be a good one. Before Aaron comes up here, I want to tell you a little bit about him. Aaron is the director of the Insperity Observatory in Humble, Texas. And if you haven't been to this place, you need to go. It's an incredible accomplishment. They got a lot of great equipment. There's a lot of great people that work there. He's also the observing director for the Astronomical League, an international organization of over 22,000 amateur astronomers. He's a retired astronomy professor. He's was retired 18 years from the Lone Star College. He's the author of 8 observing programs with the Astronomical League. He is a solar system ambassador and a past president of the North Houston Astronomy Club. So join me in welcoming Aaron, Dr. Aaron Clevenson.
How do I turn it on? You didn't tell me that.
Oh yeah, hold on.
Put my glasses on, I won't be able to see the audience.
One demerit.
Okay, thank you. And thank you all. Good to see you all this evening. I just realized it's been a long time since I've been here, pre-COVID, I think. So it is good to be back. I always hate to give presentations at astronomy club meetings because I know there are people out there in the audience who know more than I do. So if you do, that's okay. And if I make a mistake, just point it out. I don't have a problem with that either. Wait for a microphone, but I don't have a problem with you pointing out my mistakes. And my talks, and I appreciate Doug's wonderful introduction, but my talks tend to be a little bit fluffy. Usually they don't have to be, but usually they are. And it's to get people thinking. So that's kind of the theme tonight, was to get people thinking about these things. And I'm sure you've heard about all of them, or most of you probably have heard about all of them. And let's just see how this goes. Okay, so known mysteries of the universe. I added the word known because if they're unknown, we don't know that they're out there, so we don't know about them. And I've got a bunch I'm going to talk about. My agenda will show you what I'm going to cover. I do need to mention the 2 things. Doug did mention them, but I am the director of the Insperity Observatory up in Humble, and you are all invited. Send me an email so we can get you on the list, because we are taking reservations still. And we're open on the first Friday of every month. So let's see, this is April, so May is already filled. Wait a minute, we're in May. May is already gone. June is already filled, so we're working on July right now. The other thing I need to mention is the Astronomical League. And I just want to mention one thing real quick before I begin. And I know that this club officially is not part of the Astronomical League, but this is not a problem. But if any of you have any people who are 10 years old or younger in your life that you would like to introduce to astronomy and do it a little bit formally, I brought a bunch of these with me tonight, and they are free from the Astronomical League. And they do come with a pin and a certificate. Thank you, NASA. So if anybody is interested, just come see me after the meeting tonight, and I would just love to give you these. They're also suitable if you have a Boy Scout troop or a Girl Scout troop that you work with and you'd like to do something a little more formal with them. Those I'll send to you because we have workbooks as well as the manuals. It's called Sky Puppy, and it's just a very general introduction. Okay, so let's go ahead and see where we can go. So you already heard all that, so I'm just going to skip it. Okay, so mysteries. There's a lot of mysteries out there. And the more we find we don't know. Therefore, we're always finding new mysteries. And these are the 6 that I want to talk about very briefly tonight. So I'm not going to go into a lot of detail. Actually, there isn't a whole lot of detail because they're mysteries. If we knew it all already, then they wouldn't be on the list. So gravitational waves, my personal favorite, by the way. Dark matter, dark energy, black holes, the Big Bang, and life beyond Earth. So yeah, I know there's a whole bunch more, and if you have suggestions, give them to me after the presentation. I'll add them. Maybe I'll do another one of these. Okay, so before I get started, I thought I should at least talk a little bit about observing and the timeline for observing. So we don't know how long people have been looking at the stars, probably since there have been people that could look at the stars. And we don't know when that was. But the very first telescope, of course, was Galileo. He didn't create the telescope. He created the one he used. He didn't invent the telescope. But when he heard about it, he said, and he created one. And he's the first guy to get credit for looking at the stars. And that was back in 1610. And then in 1860, we created the first spectroscope. And that number's a little bit iffy because how do you define what the first spectroscope is? I mean, they were using prisms a long time before that. But anyway, and that's important because that lets us see a lot of detail in the light that we're looking at that we normally wouldn't be able to differentiate. You know, a star just looks like a little white dot to me, maybe color, but a little white dot. But when I use a spectroscope on it, I see all kinds of missing lines and bright lines and just all kinds of good stuff. In 1933, they discovered radio frequencies with a telescope, and that was before Penzias and Wilson. And they started saying, well, yeah, there's other waves out there, and we can use this. Moving down the line a little bit. Okay, so over here is the spectrum, gamma rays at the bottom, all the way up to radio waves at the top. So the next one was infrared. The first infrared telescope was 1959, which that is amazingly a long time ago considering, you know, how new some of this stuff is. The first gamma ray observatory was in 1961, X-ray in 1963, ultraviolet, 72. And then again, my favorite here, the first gravitational waves were discovered in 2015. And that, of course, is going to be our first topic. Okay, so why do I think this is such a big deal? I think it's a big deal because if you think about it, before 2015, everything, and I mean everything that we knew about the universe, we knew because of electromagnetic radiation, right? That sequence I just showed from gamma rays all the way up to radio waves. Everything. And then in 2015, we discovered gravitational waves. And these are not electromagnetic waves. These are actually waves in space itself, which is kind of a real funky thing if you think about it. And we'll talk about where they come from. The neat thing is Einstein's theory predicts it because remember, he thinks differently than Newton did, right? Newton said two bodies attract each other. Well, Einstein said, no, actually, a massive body, actually any body, but a massive body deforms space. And by deforming space, you get a gravity well, and things like us around the sun orbit at a line on that well. It's kind of cool. Okay, and it's caused when two massive objects are orbiting each other very closely. And we'll talk about what they've actually discovered with these, and they've found some really neat things. Okay, so here's the basic concept. I should be using my pointer, I suppose. So let's see if we can do this. Okay, so this is obviously the sun, this is the Earth out here, and this is a representation of that gravitational well. And the Earth is just sitting there orbiting because it's kind of, you know, I'm going to try to give you a really good example, and I don't have one, so I'm not going to bother. Okay, but anyway, so this is the cause. And the theory, that's obviously an artist's representation up here, but if the theory is you have two massive objects, like two black holes. They must be black holes because they're black and they look like holes. So, all right, we have two black holes. They're orbiting each other. Maybe they're getting ready to collide. And as they get closer and closer, what you notice is you get changes in space. Space actually shrinks and grows and shrinks and grows. And you may wonder, okay, how do you detect that? That's kind of pretty funky if you think about it. And they do it with these massive detectors. They're 4 kilometers long at right angles to each other. There's actually 2 tracks. And what they have is up here in the house, they've got this laser. They shoot the laser out, they split the beam, so one goes one way, one goes the other way. And it goes all the way down there 4 kilometers, hits a mirror, comes all the way back 4 kilometers, and then they recombine the waves. And if everything is set up perfectly and you don't have any gravitational waves, the space, the distance that they have to travel is exactly the same. And so they'll arrive, they'll be in phase, and you'll basically get twice the signal, or the signal you started with anyway. But if a gravitational wave is coming through here and at that precise moment, and it changes the shape of space, that laser has to go a little bit further or a little bit less. And as a result, you end up with them out of phase, which you can then detect. And that's where that picture comes from. Over here is these are them out of phase. And in this case, it's 2 objects that are actually colliding. And when they collide, it basically goes away. But as they get closer and closer, it gets bigger and bigger. And I don't know how they do this, but they have techniques where they can look at that and they can tell you the mass of the objects, the general direction the object came in, and the more detectors you have, the better the direction is. So it's actually amazing now that they have 3 of them online. When they're running all 3 of them, it's amazing what they can do. And this is what they've done. Now, I remember when this first started and I was writing them down as they did them. This was number 1, this was number 2. I got up to about 5 and then things went nuts. So they've actually detected quite a few, over 50. The vertical is how many masses, solar masses, the objects are. And what you've got, if I'm interpreting it correctly, I'll pick one I can reach. So this would be object 1, this is object 2, and that's your final object. So that's the reason for the funky bird-like graph. And they represent different types of things. So they've detected 2 black holes colliding, merging, 2 neutron stars, and then they've also seen some that were black holes and neutron stars. And of course, they can tell by the masses probably what it is. And I just think it's amazing. So lots of detections, lots of good information. And I mentioned, oh, that's bright. I mentioned that they can actually look and tell you what part of the sky it came from. So picture sky, and I don't have a really good picture of the sky, but just picture that's what's going on. So you've got one detector, you get something that looks kind of like this blue shape. We know it's out there somewhere, but that's a big chunk of sky. And when you add the second detector and the third detector, I'm going to move over here. Second detector, you get it closer. Third detector, you get even closer. So the more detectors you have, each one of them has its own part of the sky that it thinks it saw it in. And when you combine those, you get a much better information. And what's cool about these is they've got it set up now that when they detect one of these, they have optical telescopes and other telescopes, but optical telescopes that point to that source and try to see if they see anything. Is there an optical part of this as well? And they have found some, which is kind of cool. Okay, I have put some comics in here. Nobody's going to turn me in, right? Because I don't want to go to jail. And I will read this, just, it's big enough, but I'll read anyway. The gravitational wave detector works. For the first time, we can listen in on the signals carried by ripples in the fabric of space itself. So far, so good. Event, black hole merger in Carina, 30 masses, 30 masses. Event, Zorax the Mighty would like to connect on LinkedIn. And I'm going to stop there. So there's a few fictitious things mixed in there, but I thought it was kind of cute. Okay, so that's gravitational waves. And again, for me, that is the most significant thing that has happened in my lifetime astronomy-wise, in my opinion. Okay, so the next thing is dark matter. And I get a kick out of this. So if you look at what we believe is out there for matter, this blue wedge there represents normal matter, right? That's us, the planet, the sun, stars, all that. But then there's this big purple chunk that is dark matter. And so why dark matter? Well, it's dark because we have no idea what it is. And what else are you going to call it? I guess you could call it black, like black holes, right? But no, they call it dark matter. It's matter because it only interacts with other things through gravity. And gravity is a function of mass, which is matter, right? So, okay. So therefore, dark matter. And 84% of all the known matter is dark matter. That's a big chunk. And it's an even bigger chunk when you think about, and we don't know what it is. You know, if we knew what it was, that'd be all right. And there are theories, there's lots of theories, and I think I mentioned a few on one of the slides coming up. Okay, so how do we know it's out there? You're also not supposed to be looking at this. I thought I removed all of these, but I missed one. That's not my image, so I felt guilty using somebody else's image. But anyway, if you look at galaxy clusters, you know, there's lots of galaxies out here, right? We recognize galaxies. Those are galaxies. And of course, there's stars, right? There's always stars. But there are these weird streaks all over the place. And those streaks are distant background galaxies or protogalaxies. And when they study those spectroscopically, right? So we're back using the spectroscope again. When they studied them spectroscopically, they discovered they're not different galaxies. They're the same galaxy. Well, there's probably more than one, but a lot of them represent the same galaxy. And what's happening is it's gravitational lensing. But when they look at the galaxies and how the matter is distributed, the visible normal matter, it doesn't make sense. There's something missing. And dark matter, that's where all that dark matter is. So we have dark matter outside of our galaxy. I will come back to that one in a second. But we also have dark matter in galaxy clusters, and a lot of it. The top graph up here at the top represents what we see when we look at galaxies. And I don't believe this is ours. I don't remember which one it was. But when you look at the equations, you would think as you move away from the center of a galaxy, you get to a point where you have less and less stars, less and less matter, and so you should get that red curve. The rotation curve for the objects out there, it should drop off because you don't have any new mass. And what they found instead was the white one, the measured one, which is matter plus dark matter. And there's got to be something out there that we don't know what it is that's causing that galaxy rotation curve to stabilize. Okay, so this is recent. This is from the James Webb Telescope. And this is another one of those problems that, oh, I should back up here. I was going to say this earlier and I didn't. So anytime something new and different and hard to explain shows up, people jump to all kinds of conclusions. And they did that with this. They said, oh, goodness, there are things in this picture, which we'll talk about, but there are things in this picture which means the Big Bang Theory is wrong. No, there are things that need to be explained, but that doesn't mean it's wrong. It may have, you know, some pieces that are missing still, but really. All right, so what we're looking at in this picture, and can I find one? I'm going to make this up, but we'll pretend this one right here. Well, this one's even better. We'll use this one. That's a little red galaxy. And when they study that galaxy spectroscopically, they notice it has this incredibly huge cosmological redshift, much bigger than it should have. So what that means is that galaxy formed much earlier in the universe than their theories suggest it should have. Well, originally those theories were based on the matter we know about, right? Real normal matter. But if you take into account dark matter, it makes sense because those initial galaxies, those initial stars can form using the influence of dark matter as well. So, mysterious, yes. Unusual, odd, certainly. But, you know, it doesn't break anything. It just increases our understanding and knowledge. Okay. And I'm really impressed that they can do this. This is, you know, way up here as far as my knowledge is concerned. But this is actually a dark matter map. So they were looking at a galaxy cluster, and I can't remember which one. And the data came from Hubble. So this is old data at this point. But what they ended up with is we believe we've got these clumps of dark matter out there based on what we're seeing in the image. Pretty cool. We still don't know what it is, but we know where it is. We know what it looks like in a very general sense, but Okay, just more mysteries. And of course, I had to have a funny for this one too. So, okay, so dark matter candidates. So I don't even know where to start on this one. Well, yeah, but that's up here at the end. I'll get to that. Anyway, so you have axions, sterile neutrinos, and I'm not sure exactly what that means, but okay. Electrons painted with space camouflage, right? We can't see it, so okay. Neutralinos, cue balls, pollen, bees, no-see-ums. Definitely the no-see-ums are out there. I can vouch for that. Space cows, I love that. Obelisks, monoliths, and pyramids. Gamma rays, which that's not mass, but okay. GRB lensing, neutron star data, microlensing, solar system stability. Not sure what they mean by that, but okay. Buzzkill astronomers, thank you, Justin. And maybe those orbit lines and space diagrams are real and very heavy. You could also use the same thing for constellation lines if you prefer constellations. Anyway, thought it was cute, and I really like the fact that they put mass on them. Whoop. All right, so let's be serious for a moment. So back to the dark matter. These are some of the theories. They all have issues, so none of them are perfect. And the thing about a scientific theory is you can never actually prove it. You can find evidence that supports it, but you can't prove it. But it's not a scientific theory until you have a way to test it. And since dark matter tends not to interact with anything except through gravity, it's kind of hard to go out there and do tests on it. But I thought there were some interesting things. So baryonic dark matter, that's ordinary matter, just too cold to be seen. And I could see in a galaxy, we know we've got this disk of material and it's forming stars. We know star formation moves outward in the disk over eons. So there's probably dust and gas out there, but probably not enough. So I understand where the theory comes from, but there's holes in it. Neutrinos, if you think about it, there are trillions and trillions of them. In fact, there are trillions coursing through your body every second. And yeah, they're almost massless, but if you had trillions and trillions of them, that would be some mass, and of course we can't see it. We can barely detect them. Okay, massive compact halo objects, machos, love the acronyms. So they're compact, heavy, and invisible. Well, that's a nice theory, but you still got to test it. So, all right. And they gave some examples. Brown dwarfs, okay, black holes, rogue planets. There are theories that say there's lots of rogue planets out there wandering the universe, and that's probably true, but planets, although massive, are not that massive. Okay, and then if you got machos, you've got to have wimps. So we have weakly interacting massive objects, and these are massive particles that, for some strange reason, do not emit or absorb light and largely interact through the weak force and, of course, gravity. So, well, those are nice. But again, let's see the evidence. Let's go out there and find a way to test it. So I'm a little disappointed that we aren't there yet, but they have to be mysteries, right? Got to keep those astronomers and astrophysicists employed. Okay. What about dark energy? Well, you may have noticed earlier that my pie chart had a, whatever color that is, plum, a really big chunk of plum that we hadn't talked about yet, and that is dark energy. And so again, it's dark. We have no idea what it is. It's energy because it behaves like energy. And so, and we'll talk about that in a minute. So therefore, it's dark energy. These are the two pieces we've already talked about, the dark matter and normal matter. But now, if you consider that whole circle, 73% of it, mass energy now, is dark energy. We don't have a clue what that is. Well, that's even more frightening because now we end up with about 4% that we are normal matter, and just a whole bunch of stuff that we haven't got a clue. So if any of you are looking for a job, there's lots of opportunity out there. Okay, so what about dark energy? So I'm pretty sure most of you know that the universe is expanding, and as it's expanding, that expansion rate is accelerating. Okay, so why? We have no idea. But the shape of that curve, that's the expansion curve, right? You started down here at the Big Bang at the bottom, and then you have inflation. We're going to skip that. That's another topic. But anyway, you start growing, growing, growing. We're up here somewhere in the middle, probably the one just short of the top, is what we look like today. And we know in the future we're going to be even bigger. And they know we're accelerating because when they study distant galaxies, again, looking for redshifts, spectroscopy, they notice that some of these are moving away really fast. And the further you go, the further back in time, therefore the further away you are, the faster they're moving. So it's quite an issue. Okay, so I have to pause here just for a second and say, Doug, you did not put the last presentation I sent you in, because this one has all the old graphics in it, but that's okay. That's all right. Anyway, so back to the dark energy. So what's the result of all this? Well, space is expanding. Space is expanding really, really fast. Now, it's not expanding everywhere. I'm jumping ahead of myself. Maybe it's on the next slide. It's not expanding everywhere, right? If you think about it, the Andromeda galaxy, bigger than us, is very rapidly heading in our direction, or we're heading in its direction, depending on your perspective. Well, that doesn't sound like space is expanding. Well, it's not, it's gravity. And gravity on shorter distance scales is much stronger than the expansion of space. So in my mind, what I think is, well, it's expanding, it's just expanding past the galaxy. It's expanding, but gravity's pulling the galaxies together. Okay, anyway, so that's this one. Gravity wins for nearby objects. I think, I love things that don't quite make sense to me, and I have to really sit and think about them. This next one is one of those. If it's expanding, and the further away you are, the more it's expanding, and the faster that rate's changing, then that means there are galaxies out there that from our perspective are moving away from us faster than the speed of light. Nothing moves faster than the speed of light. So there's a real key important thing here to remember, and it doesn't mean it's moving faster than the speed of light. It means the distance between us is growing faster than the speed of light. Very important distinction. And then that leads me to this conclusion, which is that means we should see, I suppose over hundreds of years, but we should see galaxies disappearing, right? There's a galaxy there, oops, it's gone. Because the minute it crosses the speed of light threshold, we won't be able to see it anymore. Interesting. And the reason this is important, and so this comes back to the dark energy decides or helps you decide what that curve looks like. So if you go back over to these over here, they're failed theories now. They don't think that these are true. But the first one obviously is the big crunch, right? That we have so much mass out there that we're eventually going to stop expanding and we're going to come back and contract and I suppose go back to the Big Bang. Nice thought, but since we are expanding and that expansion is accelerating, that's not happening. Steady state, this is also a version of a type of steady state, but we think it's more like this. And why it's important to us, in a very general sense, is these are the Big Bangs. And depending on what that curve looks like, it determines how long ago the Big Bang occurred, which I suppose does not affect our daily lives, but it's kind of an interesting thought. And so when you think 13.8 billion years, it's this one. Okay. And for dark energy, Erna, they're playing with the Ouija board. Not again. We summon the devil. Just when I clear the office of dark energy, they invite it back in. Okay. Dark energy comics are hard to find. All right. Black holes. This is another really cool thing that happened fairly recently. In 2022, they were able to image, and that word's in quotes intentionally, the first black hole. It was frustrating me, as was mentioned by Doug. I've been teaching astronomy for 18 years, and for all 18 of those years, because I retired before this was discovered, but for all 18 of those years, I was telling my students, we can't take a picture of a black hole. Because if you think about it, it's black, it looks like a hole. Light doesn't escape. How can you take a picture of it in the first place? And they're always shrouded in dust. Well, if you can use radio telescopes, you can go through that dust and you can get a picture that looks something like that. And obviously the black hole is the thing in the center, and it matched very closely to what theory said it should look like as far as the concentrations and the strength of the field around it. Okay, pretty cool. So this was the first one. I don't know if they've done any more or not, but I do think that's cool. And just for anyone who, I know you all know, but just in case, black holes is that situation where you have so much gravity because of so much mass in such a small area that the escape velocity is greater than the speed of light. And the edge of that black hole, the event horizon, is where that distance is now the speed of light. So beyond that, you can still see. So we get to see the dust orbiting around the black hole. We just can't see the black hole itself. So we can't see inside, which is a real bummer. So one of the mysteries is we haven't got a clue what's going on inside a black hole. Yeah, we've got theories, but again, scientific theories aren't any good unless you can test them. So for me, that doesn't work. So we can't see inside them, and since everything we've known up to this point has been electromagnetic radiation, you know, that's a big zero. We can't see anything. And as far as we can tell, if you look at it from a standpoint of a physicist, the laws of physics break down. Because now you've got so much gravity, so much mass. You know, the common way that we think about it is everything inside has shrunk down to a singularity, a single point. That's not necessarily true, but it's a convenient way to think about it. But it's a real problem. You know, we can't describe it. There are a few places like that. This is one of those. All right, well, how do we know that they exist? So again, using radio telescopes, those are trails, orbits of stars that are orbiting something in the center of the galaxy. And if I'm not mistaken, this was our galaxy. So this is the core of our galaxy. Somewhere, let's see if I can point at it. Somewhere right about, oh, and it's kind of appropriate, we have this big red dot. Somewhere right about there is the black hole. But you can't see it. So when we look at this, we say, all right, we got stars, and when we calculate those orbits, we can figure out pretty much the mass of those stars. And they're obviously orbiting something, which we can calculate that mass, roughly. And so if we know that mass, how come we can't see it? You know, normally you would think something that massive, like a galaxy in itself, you can see it, right? It's there, but there's nothing there. So there's something there. It's about 4.3 million times the mass of the sun. That's a big mass. And we can't detect it at any frequencies of the electromagnetic spectrum. And in the case of ours, since it is one, it's not going to create any gravitational waves unless, you know, when we meet up with Andromeda in 3 billion years and the two black holes merge, that would be an impressive thing. But for right now, there's no way to use gravitational waves on it because you have to have something that distorts space. Okay, and now what have I done? Well, obviously I've killed that. Okay. Why do you have a miniature black hole on your coffee table? It really brings the room together. All right, corny, but you know. All right, and then this isn't the last one, but almost the last one, the Big Bang. This is another really cool and very hard to get your head around concept. And I'm going to share something with you that I got from a presenter who came to the North Houston Astronomy Club meeting. Because again, I've been teaching for 18 years. There are things that bother me. in what we normally teach. And so I occasionally came up with something that I would refer to as Clevenson's theory. Because I can't prove it, I can't even prove it makes sense, but this is something that I believe. I'll share those with you in a little bit. Okay, so this is an image. This is not the one that Wilson and Penzias did. Theirs was actually very rudimentary. But this one is from WMAP, I think. And those colors, so that big oval up there is the universe from our perspective. So we're not on there because we're in the middle of that sphere. But when you look at the universe from our perspective, it's almost the same temperature everywhere. Very constant. And when we measure that, we're measuring it in microwave radiation, radio waves. And when we look at that, we see a little bit of fluctuation, but I mean very little. So, of course, astronomers like to do things in Kelvin. So our temperature scale is Kelvin. And the differences there, even between like the red and the blue, which are the two extremes, are microkelvins, thousandths of a degree. So essentially insignificant, but they're there. And the fact that they're there is significant. Okay, so I was talking to this presenter and I said, answer me this. How do you know that's not caused by something else? And he says, well, we have theories, and I don't understand this, so I'm just going to parrot what he said. But we have theories that say, based on what the universe should have looked like back then, which is somewhere on the order of 400,000 years after the Big Bang. Am I close? Okay, thank you. Just pull that out of the air, but all right. At that time, knowing what the universe should have been like, there would have been protons and there would have been, other small particles flying around. And based on those, we know what they would have done to this chart. And this distribution is wrong for that. So it's got to be caused by something else. And that led me to my second question for him, which was, all right, and this is Clevenson theory number one. It seems to me that we had inflation. And if you buy the inflation theory, which I do, okay, so we had inflation. And we have quantum mechanics. Quantum mechanics, one of the concepts there is nothing is smooth, everything is bumpy. So very turbulent. So if you could look at a scale small enough, you would notice the turbulence. Of course, it's very, very small, so we don't see it normally. I said, so we have a turbulent universe, and then you run it through inflation where things blow up by 10 to the 50th in size. Isn't that what that is? And he said, yeah. So yes, Clevenson theory number one was right. Anyway, maybe. But okay, so this is roughly 13.8 billion years ago, because on that scale, 400,000 is nothing. We can only see back to this point because this is where things went clear for photons. This was where the electrons weren't out there swimming around the soup. They were actually combining into atoms. And when they did that, that meant photons now could travel. Before then, it was just too soupy. It was more like a stew instead of a broth. So things got much clearer. Now all of a sudden the light can travel and it's out there. And at the time, should I get this right? At the time, it was infrared. So we know it has changed a lot, right? Going from infrared to radio, that's a big change. So, okay. All right. So just another way to look at the expansion of the universe, very creative. Present day is kind of where the hazy yellow has now disappeared, and it goes a little bit into the future, but basically that's us with our big galaxies, right? So the universe is expanding, therefore it had to have been smaller in the past. Okay, that makes perfect sense. At some point, you go to an infinite energy density, and when you hit that, that's the Big Bang. So it's energy because there was no matter at that time. It was all energy. We're going to come back to this one again too. But at that time, way back then, in fact, for the 10 to the minus 43 seconds after the Big Bang, So that's, it's a Planck constant. Anyway, tiny, tiny amount of time, that was the Big Bang. And we have no clue what went on during that epoch. And the reason for that is we can't tell. We have the same problem we have with black holes. We can't tell what's going on because we can't see it, right? We can only go back to 380,000 years after the Big Bang. So we definitely can't go back this far. And our laws of physics start to break down when you get there because we don't know how to deal with infinite energy. I mean, just, it doesn't work. And very hard to test in a laboratory. So you got another problem. Okay, so, and I didn't bring my favorite. I have a graphic for the Big Bang that looked like something out of the 60s. I mean, just, it was amazing. I just unfortunately could not find it, so I didn't bring it tonight. Okay, so the Big Bang, this is as close as I get to touching on religion tonight. It was a lot easier to keep an eye on things before the Big Bang. Everything was all in one place then. Okay, so that was the Big Bang. All right, so now I'm going to deviate a little before I go into my very last topic. And so I want a show of hands. How many of you have seen a UFO? Don't ruin my punchline. Okay, so we've got a small crowd, let's say about a fifth maybe of the classroom. So I want you all to know that I love you all very much. And so this is meant in a very friendly way, but you're all liars. Because everybody has seen a UFO. And so I went out and grabbed one of the military ones. But anyway, everybody's seen a UFO because, as you pointed out, Connie, it's an unidentified flying object. If you see something in the air and you don't know what it is, it's a UFO. Yeah. Yeah. And right. And so it doesn't have to be ET. That's where people make the leap that you shouldn't be making, because unless you actually meet them, it's hard to say it's ET. All right. Anyway, so do I know what this is? Heck no. But I'm actually of the opinion it's probably not something extraterrestrial. Anyway, so I have another question. How many of you think there is life out there in the universe? Okay, that's almost everybody. And if you ask me as a scientist, the answer is no, because we haven't discovered it. So once we find it, then the answer is yes. But, and one of my favorite expressions is, the absence of evidence is not evidence of absence. So just because we can't see them and haven't found them doesn't mean they're not out there. So again, that's one of our little human things. Stop that. Just keep your mind open. Okay, so I'm a scientist. I don't like the answer, well, we don't know because we haven't found any. So I wanted to go through and figure out whether it's likely that it's out there. And I saw a large number of hands go up, so therefore you all think it's likely, as I do. So if it exists, I'm confident it will look nothing like us. I could be wrong, but I'm still pretty confident. We have not found any evidence. Now, what are the odds? All right, so I started thinking about this. So there's an equation out there. It's called I'm getting ahead of myself. Let me back off on that. So in our galaxy, there are 200 billion or so stars. And I've seen some astrophysicists who think there's 100 billion. I've seen some that think there's 300 billion. So I'm going to split the difference. It's 200 billion. Okay. There are trillions of galaxies that we're pretty confident are out there. So if you also believe that every star is likely to have some kind of a planet, doesn't mean it's habitable, doesn't mean it has life on it, but just a planet. My understanding of how planets and stars form, I can't think of why you would have a star without a planet. Okay, so therefore I think they all have planets. All right, so then that means we have, I can't even say this, 200 quintillion planets out there in our galaxy alone. No, I'm sorry, this is the universe. So in the whole universe. I find it almost impossible to believe there's not some kind of life out there. I mean, who knows what it might be like? It might only be microbial, or if they've been around a lot longer than us, they may be far advanced from what we are. But it's got to be out there. There's just too many planets. Okay, I'm going to jump ahead quick, but I may come back. Okay. I wanted to make sure I had this slide. How many of you think they have visited us here on Earth? Got a few. Okay, cool. All right, so again, I've never seen one. And as the one up here says, there is no concrete evidence that they've been here. Sorry, ancient aliens. Because yes, humans could have built the pyramids. I'm using that as an example, but it covers all of it. And the reason for that is humans way back then, so that was what, 4,000 or 5,000 years ago? Humans way back then were as smart as we are. They don't know everything we know scientifically. They don't have the technology that we have, certainly, but they knew things and they knew how to study things. So they would have been able to, and if you look at the pyramids, their first pyramids were not very good. I mean, so they got better. So it sounds human to me. But anyway, this is where I was going a minute ago. The Drake equation. Everybody familiar with the Drake equation? Not everybody. So I'm going to go ahead and elaborate a little. You can find it on the internet. Make sure you pick an interactive Drake equation, because if you don't, you have to do the math, and a little of it's pretty squirrely. So it's better to let the computer do it. Anyway, it will tell you the number of intelligent species in your galaxy that are trying to communicate with you. Now, you have to realize that every number that it asks you for, and there's about 10 of them, is a wild guess. And your guess is as good as mine, because we don't know the answer to those questions. But the first one, if you use a 200 billion, that's probably close enough to fact. Okay, so I ran this twice. I did it 20 years ago, and I did it about 2 months ago. And as bizarre as it sounds, I get the same answer twice. And I know my answers to the questions were different because what we've discovered since then has changed. But I came up with 2,000 in the Milky Way. All right, so now I got to think, have they been here? And so my first thought is, well, okay, 2,000 in a galaxy that's shaped like a CD, but it's 100,000 light years across. So now I'm going to take my 2,000 rather, civilizations, and I'm going to sprinkle them on that disk. It's likely none of them are anywhere near us. I mean, they could be. Andromeda, oh, sorry, wrong one. Alpha Centauri is very sun-like. And so if you maintain it's got to be sun-like to have life on planets, then that's a possibility. And it's only 4.5 or so light years away. That's not bad. But really, on average, big distance. Okay. So I'm convinced they probably have not been here. Now, there's a few, obviously it doesn't like me walking around. There's a few other little tidbits I want to throw in at this point on this slide. And that is, if they have eyes that see like ours, so there's a big if there, right? Since who knows, but I got to start somewhere. So I assume if they have eyes that are like ours and they're 30 light years away, they will not be able to see the sun naked eye. Now, I'm willing to make another leap here, and that is they've got telescopes, just like we do. Okay. So they can see the sun. And then the other question I ask myself is, if it were me, would I spend the time, money, and effort to go somewhere where I didn't know there was something there worth going to? Sorry, Star Trek. No, I would not. I mean, I think it's great to go out there and explore the universe and all that good stuff, but the reality is it's expensive. So, yeah, and of course we can't go faster than the speed of light, so we have some serious issues, right? If you think about it, probes that we launched 50 years ago are just now leaving the strong part of the sun's influence. They haven't left the solar system yet because they haven't reached the Oort cloud, if it's out there. So that's another theory, another topic. Anyway, so I'm not overly optimistic. All right, and these are easy, right? Because Larson did a whole bunch of these. Inadvertently, Roy dooms the entire Earth to annihilation when, in an attempt to be friendly, he seizes their leader by the head and shakes vigorously. I really like that one. Okay, I am going to take questions. but I am going to put this slide up just so anybody will have that information if you want it. So if you do want to reach me, that's my email. It's a personal email, but I read it all the time. So if you have any questions, comments, thoughts, suggestions, I'll accept all that. Just send it to me. These are the 3 websites that are most important to me personally. The Insperity Observatory is up in Humble. Already talked about that. This is the Astronomical League. And this one is the North Houston Astronomy Club. Okay, questions? Suppose I should do the song and dance while we're waiting for the microphone.
When you showed the universe there, it was oblate or oval shaped. So wouldn't it be a sphere?
I can't explain why it's not a sphere. It doesn't bother me it's not a sphere, but I can't explain why it's not. Do you have any idea why they're always oblate? When they did the cosmic microwave background radiation.
It's just the projection they use to map out the whole sky to give it accuracy in terms of the spatial. Because if you do like a Mercator projection, you're going to get all your measurements wrong. They use just a simple orthographic projection.
Thank you, Justin. I went to Justin because I'm an astronomer. Justin is an astrophysicist. So tough questions, I'm going to defer to him. Any other questions? Yes, sir.
You put together the heck of an observatory in Humble. How did you pull it off?
Ooh, good question. So I'll give you a very brief history of what happened when we went to do the observatory. We have in the Humble School District, they have an educational foundation. They'd been giving grants to teachers for years, and they said, we want to do something big that's bigger than the school district even. And it was not even my idea. I can't take credit for the idea, but somebody mentioned, along with, there were probably a dozen. There were 23 submissions, but there were about a dozen ideas initially. And one of them was an observatory. And how can you lose? There is nothing better than an observatory. So it went through the process. It came out #1. So that was how it all started. How we made it happen was the foundation went out to raise money, the Insperity, because we are the Insperity Observatory. The Insperity Company, which is up there just north of Humble, had a fundraiser with their employees. They raised an incredible amount of money, which the company then turned around and matched, hence the naming rights. And then on the downside of that, just because you said pull it off, the downside of that was it took us over 5 years from the time we scoped it out and spec'd it out till we built it. The price of construction went up 3x. So we got the building built and had no telescopes in it. It was really sad. The architect said, build it now or you're never going to build it. And so he said, okay. And that was it. And the school district has been wonderful to work with. We are fairly autonomous. We're not in their budget. And the good thing of that is when they have a bad year and they have to cut budgets, they can't cut mine because I don't have one. Now, the downside of that is I don't have a budget. But we exist through donations, still and yet. And we're all volunteers, including me, the director. So, and like I said, the autonomy is a big thing. I wouldn't still be there if they took that away because they just say, run it. Anyway, thank you though for asking. Yes, sir.
This is more of a philosophical one. Whenever we talk about the distances and, we think about it the way we think today. But I never hear anybody sort of couch it. Now, and I'll put it this way. If the dinosaurs had died, 3 million years before, okay, so we've got 3 more million years from where we are today in our technology, our thought processes, and we look at how we're accelerating right now. never try to put ourselves and think that far ahead in what's possible.
You're
And so
absolutely
we
right.
always, everyone who ever explains it limits themselves to saying it just can't be. It's just too far. It's, you know, it's not going to happen.
Well, I did couch that statement with they could be
Well,
technically
and
much
I'm
more
not picking
advanced.
on you.
No, no, I
You know,
understand. I understand. I'm not
yeah.
really being defensive. Um, I can answer that for me personally. I can't answer it for the general populace. I think for most people, and probably the people in this room are exempt from what I'm about to say first, is they haven't got a clue. And so for them, they couldn't tell you what's going to look like other than what they've seen on TV or in movies. As for me, all right, so I do have a science background. I do astronomy. I should be able to think the way you're suggesting. My problem is it's there, you know, in a million years, 1,000 years actually, we will be way advanced from where we are today. I have no idea what it'll look like. I mean, my brain just doesn't go that far. So I'm confident it's going to happen. I am confident that it could have happened elsewhere in the universe, or let's say galaxy, elsewhere in the galaxy, and they could have come and visited us. I'm just looking for the evidence. But I don't know. You know, I like to think in terms of I'm a Trekkie, so I think in terms of Star Trek, we're going to have these wonderful starships and we're going to have warp drive. I'm confident. But that's as far as I can go because, you know, we're not there yet. We haven't figured out how to do that. Good point, though. I mean, but I don't know how to do it.
So, Aaron, I have a question for you. Why are you only open one night a month at the observatory?
Okay, do we have any F-back people here? So at the risk of misquoting or offending you, and I'm not trying to offend you, because that's, of course, the other big observatory in town, right? So, and bigger than ours. I'll give them credit for that. They're open every weekend, I think every Saturday. And, well, yeah, the weather, well, yeah, you can't see anything if the weather doesn't cooperate, but yeah. So why do we only do it once a month? And the reason we do it once a month is we're all volunteers, just like at the George, and I don't want to burn out my astronomers. So initially we weren't limiting the number of people on public nights, and we were averaging, I guess pre-COVID, we got up to 75 to 100 people a night, which is a lot of people, and it's a little observatory, but it worked. And yeah, they would come and go, so they weren't all there at once. Our peak load has been 198 in one night. I don't ever want to see that again. And then I wasn't there, but I'm going to brag about it anyway, for the, make sure I get the right one, transit of Venus when it happened. I was not here because, oh, wait a minute, that's not right. I was here. It was either that one or the total eclipse, which of course wasn't total in Houston, but okay. One of those two, and I can't remember which one, 4,500 people. Yeah. But the reason we only do it once a month is burnout. We do private groups at other times of the month. Our primary responsibility is to the students of Humble ISD. So our high schools all teach astronomy. Their classes can come once a month. Lone Star College, only because it's local, but Kingwood, North Harris, and Montgomery, because I used to teach at Montgomery, can come once a month with their students, astronomy students. And in the district, middle schools and elementary schools can sign up and come once a semester if they want. So we have that. That's not overloading us because they're not truly taking advantage of that. And we're working on that. And then the private groups. And since we don't get any money, and if you're not part of the school district, we do charge or we ask for a donation to the foundation. And that's where we get our operating money from. So. Sure. All right. Thank you all.
Thanks, Aaron. That was great. Thank you. All righty. Oh, Where are we? Okay, so Ron, you want to tell us about the DVD library? You got a microphone up there? All right.
I've just added another 30 DVDs that have been donated. And what you'll find the most of there out front, there's about 200 of them right now. But if they're marked IC in the legend, that those are Infinite Cosmos, that's by Astronomy Magazine. So that's the majority of them. Now we also have many actually, great courses also. And those are Astronomy Magazines, theirs are about 45 minutes long. You can always count on about 10 hours on with the great courses. Now we also have moon maps, planispheres, 4 sky atlases, and they're plastic coated, so you use them outside. And if it's marked black, that means it's missing. If it's marked red out there, that means that somebody's borrowed it. And I also have a DVD that was, we got one returned today by Kevin. 3 years, he brought it back. Now here's the one I'm most concerned about. It's Sex in Space. They returned it, but they kept the DVD. So, who's the culprit? Anyway, thank you.
Okay, and Ron, you had a suggestion that you want to let Andy tell us about LPI. Ron, are you still paying attention to me? Ron, I'm talking to you. Your suggestion was you want Andy to tell us about LPI. Oh, Andy gone now? Okay, forget that. All right, so after the meeting, we're going to have the meeting after the meeting at Mod Pizza. If you don't know where it is, you come out here, you go up Millbrook North, you take a left on Clear Lake City Boulevard, past El Dorado, right in front of HEB. There's a Mod Pizza. We'll all get together and talk about astronomy and other related topics. And we are going to take a 10-minute break and be back here and start up the second half of our meeting, which has these topics. See you in 10 minutes.
Hi, Aaron. Good to meet you. Good to meet you. The 10 and under piece is back. Matter if they're over 10. But for 10 and unders, they're eligible to get a certificate. Oh, yeah, that's right.
hard to see that. I mean, you can look here, but it's, you know, but you're trying to gesture to everybody when looking at the screen. So.
Yes, wonderful. Get him to do it before he.
Okay, 10 minutes are up and we're gonna get started. Going to get started.
Good talking with you, Eric. Yep, you too.
Going to get started. You still got a mic, right? Okay. You guys don't believe me that we're gonna get started, do you? I know. Okay, I'm gonna get the cowbell out here in about 2 seconds. Yeah. 5, 4, 3, 2, 1. I'm getting the cowbell out. I'm telling you. Okay. All right. Welcome to the second half of our meeting today. First thing we're going to do, okay, first I'm going to do a members minute, and then we got a couple walk-ons here. All right, so I'm going to do a members minute, wind, X-bar, and RR Lyra stars. So a few of us went out to the X-bar ranch last month, and it was windy, but even though we were still able to do some astronomical projects that we've been wanting to do, one of the ones I want to do is get some videos of some RR Lyra stars. So what's an RR Lyra star? It's a variable star that has a period luminosity relationship that connects the period of pulsations to its luminosity. And because the period is from about 4 hours to 2 days, so the time it goes from bright to dark to bright again, is something you can actually do in a couple nights of being out at a star party. So if you can find the absolute luminosity and thus the magnitude, you can figure out what the distance is by comparing to the parent magnitude, the magnitude that you actually see. An absolute magnitude is defined by how bright a star is if it's set at 10 parsecs, which is a distance, 10 parsecs. So 10 parsecs, how bright would the star be? That's what's defined as absolute magnitude. RR Lyra stars are named after a star that's in constellation Lyra, and the reason they named it after that one is because it's the brightest in the class. And it's one of the standard candles that's used to determine distance. So the goal was to try to get a video of these RR Lyra stars with an amateur telescope setup, and this is a video. Okay, so this is taken over 2 nights. Thank you for the awesome, whoever that was. This is taken over 2 nights, but then it's compressed. Thank you. It's compressed into a 7-second video over 2 nights, and the circled items areas have these RR Lyra stars in them. So this thing's supposed to be repeating over and over. Is it repeating? That's not right. That's the end. Hold on. Wrong way. Hold on. I am way off from where I'm supposed to be. This is the rest of the meeting, by the way. You can get a preview. Oh, wow. I wish I hadn't done that. My computer at home is much faster. In case you don't want to see the rest of the meeting, that's what it's going to be.
All right.
Now, okay, if I go down, page down, all right? And it's not running yet, right?
No.
Now hit enter.
Yes.
There they go. Now it's supposed to repeat over and over. I hope it does it. if you look in the little circles there, try to ignore all the distortion and everything that's going on with the wind and everything else that's happening. But look at the stars that are changing their brightness slowly over time. Those are the RR Lyra stars. You guys see it? Yeah. Now, thank you. Now, what's cool about this? You know, I'm always telling you guys about things amateur astronomers could do, right? And Al was there and Reed was there. They can testify about the wind, right? It's pretty windy, right? But even with all the wind, with a regular DSLR, Canon DSLR, regular astronomical, amateur telescope, I was able to, capture these images and make this video. So there's things you can do. There's lots of cool projects you can do as an amateur astronomer, and this is one example of those. Okay, now, and those again are standard candles. So supposedly by looking at their period, and you can figure out what their absolute luminosity is, and then figure out what the distance is. Then we can figure out how far this globular cluster M3 is away from us using those. Okay, and since I had 233 pictures, I thought, well, I'll combine these all together and make a picture, normal picture out of them. So that's a picture, yeah, that's a picture of M3. Normally, when I take images, I take like 10 or 20 or something, combine them together, and I feel pretty good about it. This is 233 images. So the cool thing about this is a DSLR, which isn't as good as a normal astronomical camera, but if you combine enough of these images together, you can actually get a very low noise picture, which you can see from this one's pretty good low noise picture of M3. So that is that. And if you want to see this and my other adventures in astronomy, you can look at www.holland-observatory.net. You can see all these and others. Okay, that's that. Now, we're going to do things just a little different here. I got two walk-ons. Okay, Hart, can you please do your walk-on? Come on up here.
So I'd like to announce our next speech from the LPI. It'll be held here on June 8th. That's a Thursday. That's the day before the next JSCast meeting. We'll have our very own Dr. David Krang talking about what might Artemis astronauts encounter at the lunar South Pole. Promises to be quite interesting. Hope to see you all in a month, minus a day.
7:30, Hart said.
7:30 p.m. Same time as these meetings.
Okay, thank you, Hart. I got one more walk-on. Dan, you want to come on down here? All right, stand right in front of the mic so the people online can hear you.
So you don't need your mic. Okay, I've been telling you that many times. I came today with my boss's boss. Okay, Francesco Fusco is the director of the Foundation for International Space Education. And I've been telling you about the United Space School before. I had brought with me pictures of the kids, but I had forgotten you cannot do that. This is classified stuff. So, but anyway, you have seen that before, and I'm going to let Francesco give you the real thing about the United Space School. But if you know anyone, anywhere, a good family who could host some of our kids, I would deeply appreciate that, because I'm busting my butt on it, and I still don't have much to show for it.
Okay, thank you very much, Dan. Next up, we have Austin Meredith with the UHCL Physics and Astronomy Club. He's going to tell us all about it. You guys have seen Austin around here. I'm glad he's participating tonight. I'm going to try not to goof this up for you.
So you can go to the next slide. So I'm here with the Physics and Astronomy Club with the UHCL, which is right next door. Our aim is to promote interest in physical sciences to students and community members of all backgrounds. We are trying to provide opportunities for students and the community for social, professional, and academic development, as well as involvement in education and outreach to students and the public. And I am the currently elected president of the Physics and Astronomy Club. I am pursuing my master's in computer information systems, and I have my bachelor's in computer science. I am also the vice president of administration for the student government of UHCL, and I work in the office of the president. There's my contact information if you need to contact me for any reason, but I'll continue on to why I'm here. You can go to the next one. So I'm here in search of collaboration for our club. We're seeking guest speakers or anybody who would be interested in presenting or promoting their clubs or events or any kind of specialty, or if you're doing research in anything, we would love to have some students come out and hear about what you have to present. We're also interested in some internships or any kind of opportunities that might be available for students, graduates or undergrads. We have currently 50 official, over 100 unofficial members of our club, most of which are students, most of which are undergrad students as well. We're also looking for people who might want to come out to our events, like our star parties here on campus or elsewhere. We also host tables at the different events on campus, like the resource fairs, the intern fairs, stuff like that. And we also go on club trips that you are more than welcome to join as well, so you can network with more of our students. And we're also open to any other ideas. A week from today, we are trying to plan an end of semester star party on campus. We're going to have some people from LPI, hopefully some people from JSCAS, and I heard some hopeful NASA employees might be coming along as well. So it'd be great to have some people collab on that. That'll be next Friday around the same time as this, 7:30 p.m. And next slide. This is how to contact us. Our email is pretty simple. It's just paac@uhcl.edu, or you can scan the QR. The QR will have all of our socials, as well as a way to easily link to email us. And yeah, if you have any questions, I'll take those now.
Okay, so I have one. Okay, so the event we have one on our calendar actually for tomorrow.
Yeah, so the
Yeah.
weather is not looking like it's going to be good to have anything outdoors
Okay,
tomorrow evening. So we are going to move that to a week from today.
Okay, and it's the same thing, just a week from
Yeah,
today?
it's the
So-
exact same thing, just a week from today.
So David, I guess you got it. Okay. And the same time and all that
Yep,
stuff?
same time and
Just
everything.
one-
Same,
okay.
same agenda, same everything.
So if you guys are looking at our calendar, that's wrong. David will fix it, right? Other
All right.
questions for Austin?
Thank you guys so much.
All right, thanks. Okay, I'm gonna say a couple things. Okay, so Austin, how many UH Clear Lake students are actually here tonight? Okay, thanks. All right, so listen, guys, I'm just take a minute here. Okay, I keep hearing you guys say you'd like to have like to pursue a career with JSC or one of the NASA contractors. Let me just lay this out for you, just really easy and bottom line. Rick, you can help me if you can think of something I'm saying wrong here. If you want to get a job at NASA, there's three ways to do it. You can be a direct hire, you can be a co-op student, which now they call pathways, or they can be an intern. Okay, but the bottom line is with NASA, you got to apply. That's how I got my job at NASA. I sent an application, I got a job. Okay, wasn't that? I'm not gonna say it was easy. I'm just saying that's how I got it. But you have to apply. When you get a job with a company, sometimes if you know somebody, say, I know somebody, they can get me in. It's not that way with NASA. You got to go through the process of applying through the internship program or co-op, which is also called Pathways now. The direct hire is usually if someone's got a lot of experience and they're out there, they've been working for 10 or 20 years and they got specific skills that NASA wants to hire. So they'll hire a direct hire. A student will most likely will not be a direct hire. Just hold on video. But if you guys want to be an internship program or you want to be in the co-op program, you got to get online and you got to apply on those programs. The video.
So if you want to apply at usajobs.gov. There are several posts that we receive. We receive emails all the time of openings that they have. Also, there's several contractors. Collins is hiring, Jacobs is hiring,
Axiom.
Yeah, is hiring, and they're building another facility next to the NBL. So
right.
Definitely aware of the USA Jobs and how in the Pathways program. The UHCL has a strategic partnerships program that really promotes pathways, especially. But Axiom Space, all those companies that come to campus fairly often and promote those as well.
You're aware of the internship website? 'Cause
Yeah.
Internship and pathways, I believe, are separate.
I believe the flyer that we get from Strategic Partnership has both of those.
Okay, good. Because I haven't been there for 5 years, so my information may be old. But I'm telling you, you got to apply. That's the only way to get in.
Oh yeah, well, definitely.
Okay.
We're always trying to get our students to apply.
Okay, and Rick, can you get a mic over here to Rick? Because he's a knowledgeable NASA fellow.
One thing too about applying, because what's going to happen when you apply, it actually goes through a little computer system now, where they're looking for keywords that you've got in there, and if those keywords aren't in there, you're kicked out automatically.
That's absolutely right.
Pardon? Here's the key, because I used to have to evaluate people I was going to hire, and they did go through, even back in the old days, they were going through that computer system. But what happens is you have to pay real close attention to
Ad.
Yeah, the ad that's
The
in there.
ad.
And
It has
they call it
keywords in
something
the
else.
ad.
In that ad,
right,
every word that's in there has to be in, you have to show how you're able to do it in your, what you submit. And those keywords are absolutely critical. Now they're going to look at other things too. And in many cases, they really don't have a good candidate. There were times we sent out stuff, we didn't have a good candidate that we were actually, kind of looking for or whatever. And so when they come through, but those keywords have to be in there. But more importantly than just putting the keywords in there, you want to speak to what you have done, what experience you have, not necessarily having a job. A lot of times there's certain skills that we were looking for, and they got those skills in college. And because they had actually done projects that, utilized or gave them those skills. That's key. So the
Relevant
keywords,
classes.
and then put whatever you've done. And even if you think, hey, I did some experiments or I did some work or whatever for a professor, and a lot of times that will resonate with the people that are actually doing your evaluation. That's all I got.
Absolutely. Yeah. And relevant classes too. If there's something that really is relevant to that job you're applying for, say, I took this class. Okay. Any other help for the UHCL students to get them a job? Great. Thank you, Rick. All right. Next up, let's see. Page down. Okay. We have another UHCL student. This is great. Aaron Thero is going to come up and tell us about the Cosmic Campground.
Yeah, so I'm Aaron. While you all went to, I think it was Fort McCavitt, I went somewhere else because they don't allow dogs at Fort McCavitt, and I can't leave my boy alone. In the Gila National Forest in New Mexico. That's 33 north and 108 west. That's where the minus comes in. Yeah, it'll be in the live stream later. Basically, it was founded in 2016, and it's part of a dark sky sanctuary. It's the first dark sky sanctuary in a national park. I found it just by Googling things to do in New Mexico, and I was looking at some other thing, and this came up. I wasn't intentionally trying to go here first. I wanted to go in December, but I got sick and I couldn't make it out there. It's pretty far. It's about, I think, 14 or 16 hours away.
That red dot, that's where it is. I saw the 2016 information on this, and that Bortle 1 was a little bit bigger, and actually the red dot was in the Bortle 1, but this is 2020 data. It's a little more up to date. In reality, the only light pollution I could see was this right here. And it was really low on the horizon, maybe 3-4 degrees. I couldn't see anything else. Texas, I think Fort McCavitt is somewhere. Okay. Usually I go over here, where it's Fort Davis Mountains. That's usually where I go, but I saw Cosmic Campground and I wanted to try it out. Now, just like y'all, when y'all went there, you had cloudy skies. I probably had about 40 minutes of clear skies, a few breaks in the clouds. This is obviously like Cassiopeia over here, and the northern Milky Way, and Orion. This is just taken with my phone. The Google Pixel does some kind of astro mode where it kind of like stacks it in the phone. Supposedly 4 minutes of data, but I think it's actually less. Berenices, star cluster, and Leo. And I only got to take these 3 pictures, really, maybe 4, before everything started clouding up. And what was really odd about this place is like during sunset, it seemed like it lasted a lot longer. Like there's like this glow on the horizon the whole time. I'm assuming it was a sunset. I don't know what it was. Eventually it went away. But I don't know if you've ever been in a place where it's like this dark. When there's clouds and you can see stars kind of peeking through, the clouds are actually black and they look like holes in this. Things to know. There are 4 telescope pads here. And this place follows all the traditional rules of a star party. No white lights. Gotta arrive before dark so your headlights aren't blinding people. Quiet hours. No generators. Yeah, I didn't use that. It was cold. I went March, so it was warm during the day, but if you were in the shade, which there wasn't much, but I think, they have those new generators these days where they're actually pretty quiet, and there's actually far enough places away from the main part of the campground you can stay at, where if you're running like a RV or something, it wouldn't be a problem. This is what a campsite looks like. I think there was 6 to 8 of them. They had fire rings, picnic tables, and it's not really paved, but there's gravel there. And there's like a gravel or for a tent spot too. It's kind of like gravel. Year-round camping, vault toilets. You might need to bring your own TP. Picnic tables. The camping is free. It's in the national forest. I don't know if many people know this, but they have things called dispersed camping in national forest where you just up, and if there's a spot there, you can stay there. Not really free. Your tax dollars are paying for it, so you might as well take advantage of it. No water, no sewage, 0 cell service. It took me about 2 hours driving back to actually get cellular service. It is in the middle of nowhere. Cars, you don't hear airplanes, you don't hear cars on the highway. It's great. There was a country store. I did not stop at it. Gas was expensive. It's in the middle of nowhere gas. They had food and toiletries, from what I looked up online. Yeah. How I stayed, I just threw some blankets in the back of my car. Just slept on that. I only stayed for a day just because I knew the forecast was going to be really crummy. And it was only 4 hours away from the place I was going to go. But as you can see, there's like an RV there. Some of the spots are large. I saw like one of those 23, 26 foot pull along campers. Made it just fine there. So if you were planning to go here, you could bring like your whole setup, your whole rig if you wanted to. Other things to do in the area. Catwalk recreation area is this long catwalk in a gorge that's over a river. It's absolutely stunning. And then there was hiking at Cosmic Campground. I'm not sure if it wasn't a traditional hiking trail, but I followed like the path of the water. There was no water. But yeah, it was a great time. I'd like to go back sometime. I've been to Fort Davis and all that, and it's really dark there, but you can still see some of those light domes on the horizon. I just saw that one light dome, and it wasn't even that great. So out again.
Excellent. Thank you for sharing that with us. Okay, next up, we have Francesco Fusco. That's going to tell us about the United Space School. What? And George Abbey, by the way, I never thought I'd be introducing George Abbey at one of our meetings, former director of the Johnson Space Center. There he is in all his glory. Did you want to say anything, Angie? All right. All right.
Yeah, we're gonna probably talk a little bit about it. I know there's not much time, so I'm trying to be fast, but yeah, that's the program that Dan was mentioning before, is working really hard to get some host families. So hopefully some of you, it's going to be interested. But I'll tell you about the program. So if you have any question and you want to know more about it, I'll be happy to answer. So I'm not gonna try to go quick. So there's not really an agenda. This is my graphical resume here. I came here in '99. I did an internship at Johnson Space Center actually when Mr. Abe was center director. Went back to Italy, graduated at Politecnico di Torino. I'm a propulsion engineer and worked on Eurofighter for about 4 years in a flight test. Came back here for return to flight, joined the Boeing. I'm still working for Boeing since. Became responsible engineer for the RCS thrusters, test conductor for Starliner hot-fire tests. I work on the engineer support team for the SLS launch. And I support several Air Force program, B-1B, B-52, KC-135, K-46, and many others. So enough about me. I'm not here for this. I'm here because among my work, when I arrived here, I met with Geoff and Annette Mules. They founded this International Space School Foundation, and they started from Wales. They're from Wales, so they started bringing students from Wales, introduced them to the space program, and they quickly realized that that was incredible. The kids really enjoyed it, so they started to invite more students from different countries, and that thing grow and grow. When I came here in 2003, I was approached by him if I could bring Italy into the program, and I became country manager for Italy, and I never left the foundation. In 2007, since there were some personal things attached to that International Space School, we decided to dedicate a foundation only for this because it was growing so much. And actually, Mr. Abe and myself were among the founders of FICE, which is the Foundation for International Space Education. The same people that was working with the previous. So we feel like it's one foundation that just evolved with the time. So we're starting to have this program since 1995. When I became director, we started to grow. New countries came in. We got to 55 students pre-COVID. We have to grow steady and slowly. It's mostly volunteer, as Aaron was saying before. You know how hard it is with working as a volunteer. Breaking the 50 points, it's really hard. Lots of things changed. I'm going to talk a little bit of the team later, but we had to introduce a new team. We found that we're trying to put it as perfect as we can. More than 12 people in the team is too much for what we do. So we have to have another team, and then growing even farther would have been tough. But of course, COVID now set us back a little bit. We went online. We came up with this global space school, ran it for 2 years, completely different concept. We do a mission to Mars here, but for GSS, we did a mission to an asteroid with project issues between manufacturing, building space, and transportation, and mining. So I'm going to go through the goal of the foundation, of course, is to promote STEAM education and international collaboration. Those are the 2 key points. Of course, we're going to offer the students an introduction to the aerospace industry, and we also going to introduce to the American culture. I know coming from an Italian might sound weird, but we actually try to do that. And the host families play a big role in this part. Opening the house to those students from all over the world, it's mutual beneficial. The overview, I put that first mentor selection. There's a specific reason for it. Mentors are alumni returning. You have to think that they graduated, they're probably 4 or 5 years into their job. They take 3 weeks of vacation, volunteer their time. They pay their travel to come here. And for 3 weeks, they really, really work hard, night and day. And you see, this is an amazing volunteer thing. I mean, who's going to do that? We have dozens of applications every year that we have to choose from. And to me, that's the testament we're doing something good. The kids want to just come back and give back to the program because they took so much from it. And to me, that's, okay, we're doing something good. That's what it keeps me going. You know? But we do student selection. Each country has their own arrangement. We do try to have point of contacts everywhere. Some countries, we have to do selection from here. They're, as I say, different arrangements. Some is the government, they play a role and give some funding. Some are the school, some are private foundation, some are companies, some are the student itself that pay their own way. So we try to keep the cost very low because the selection is based on merit. And we really don't want to get into the situation where merit students cannot come because there's no fund associated with it. So we keep tuition costs very, very low so everybody can access. And if a student doesn't have the money, we help them fundraising the money. I'm not going to go through all the boxes, but we do all those stages. In February, we do the mentor selection. We send the assignment in March. The assignments are there to give them some knowledge on what they're expected to do here. 2 weeks will go very fast. And they're doing a mission to Mars. So they need to know a lot of things they cannot possibly learn only in those 2 weeks. So we try to give them elements by doing the assignments. Everything they need to know are already in that assignment, and we're funneled to them that way. So when they come here, they can hit the ground and run. We do team formation, team building. They have to decide the mission parameters when they come here. I'm going to talk a little bit about that in the next chart. They have to do the proposal. These things is like they're presenting a presentation, CDR type. So we're trying to give them also an industry standard type of approach. We do a tiger team. So midway of their project, we see 3, 4 experts sit there, look through their project so far and identify flaws, and help them with the things that cannot figure it out. So the final product needs to be something consistent. And it's amazing what they can come up with. How does it work here? The United Space School itself, we do a mission to Mars. We're probably going to change next year to align better with the NASA new objectives, but we divided them in 5 teams. Each team is specific, try to set skill sets for a group of students. Mission control, yellow team, they will put together the budget. They're the one in charge of the budget. They're in charge of the mission control, communication systems, satellite, and everything, and space law. This is very important, especially if you think colonize an asteroid and start to mining. Blue team is the Mars exploration, is what we're going to do on Mars. They are the science team. So they are deciding once on Mars what kind of exploration we do. Of course, because of that, they're in charge of the rover and the spacesuit. Green team is the Mars habitation. They have to build the habitats on Mars. They're also in charge of how the astronauts live on the transfer vehicle. They do the crew selections and they do medicine, space medicine. Maroon team, they are the operational logistics. They're mostly the team that build the landers from Mars orbit to Mars and back to the main ship. If they harvest fuel from the atmosphere, they also have to stock and refurbish and refueling the spacecraft. And finally, the red team, if they go at Mars Direct, if we do a direct mission, they're in charge from Earth to Mars orbit, or if they do from LEO, they do a low Earth orbit to Mars orbit. So everyone has things to do. Each team has specific, more to the maths, more to the science, more to the medicine, and they all have to design a patch. Because arts is always part of the equation here. This chart is very busy, and that's how busy is those 2 weeks. We do a lot of activity. Everything is packed. We really, with the time, we tweak it in a way that everything is done for a purpose. Build team, we do a lot of social event because we also want to have those kids to have fun, and that's the key that makes it enthusiastic and they endure the being tired because it's so much things to do. Like soccer game, we do a team. We need to build the individual team, but we also have to build the bigger team, right? We keep telling them, it's not a competition. You want your team to excel, but if any of the team fail, you fail too, because it's overall mission. So the soccer game is to build the bigger team, like all students play against a NASA selection, right? And then, but we have also other activity where individual team plays against each other. So we try to make the things fun, but a team building all the time. Of course, we take them to Johnson Space Center. The classes we do it here at UHCL. So for a host family, it's 2 weeks. Even the time frame, it's well chosen. I think 1 week is too short. You don't even have time to know the students that come in that you host. 2 weeks is enough. 3 weeks might be too much, But we try to do it. The hardest things is to drive them in the morning. If you live close, it's much easier, of course. That's why we try to look in this area for host family. They typically start 7:45. You drop them, pick them up at 5. Sometimes they stay longer because they're evening activities. Sometimes they're evening activities. Now, the evening activities, host families are invited. They can stay, and there's a lot of fun, but they can also just drop their kids and have their free night. So we're trying to go and make everybody more comfortable with everything. We do a final presentation at University of Houston Clear Lake that is really amazing what they come up with. We add some arts in there, but it's very technical, and we ask hard questions. It's really like an exam. And we do a final graduation where typically we invite an astronauts to do a motivational speech, and we give them certificates of completion, and there will be a final video that summarizes everything they did in those 2 weeks. That usually is really a big hit. And of course, there's a lot of volunteer opportunity in the boards, but also in various committees that we run. As I said, we're really looking for host families for this year. We start to rebuild after COVID. That's why we kept the number a little lower. We're 44 students this year. We still are looking for 5 families. I'm looking at, and so hopefully we'll find it, but we have a little time. And then of course we have alternative ways that we try to keep it as a just in case. And I'm going to leave you with. So for 27 years, we had this program, and we have more than 1,000 alumni now from 32 different countries. So it's quite impressive when you put all those students together and what they can come up with. The highlights of the program is them. I keep saying that. Now, we do a lot of work to make this happen, but at the end of the day, the thing you're going to enjoy the most is yourself. And it works. And they become friends for life. It's funny because we get this Facebook page. Kids now, they only use Facebook for this thing. You can tell, but you can see that they keep doing and they keep going visit each other over the years. So and they organize a reunion and things like that. I'm gonna do a quick video that briefly summarize. How do I start? Yeah. Okay, so, well,
Go to the next slide.
maybe the video didn't make it through the cut bit. Yeah, that's our website, and that's what the video also would have finished by doing it. The video is on our website, so if you really are now interested to look at the video, you can go there and see it. It's more like an ad type where they show exactly what they do. But yeah, so this pretty in a nutshell, it's very important for the students. We want them. I know we reach only, this year 44, 50 students, but one of the requirement is that they are not a last year in their high school, because we want them to go back in their high school and bring their experience to the one that they didn't get chosen. And so we make sure they organize those events after to reach more students, of course. GSS that we run online, it's allow a test bed to allow to reach more countries, maybe multiple time a day, as we are going to rebuild some volunteer in the boards. We're probably going to start to offer that to other countries as well. That's pretty much what I have. Any question on the program?
Okay, I have a couple questions. Okay, so this is a once-a-year event, right?
The USS it is, yes.
Okay, and what are the dates?
So this year, the students will arrive July 16 and they will leave July 31st.
July 16th to July 31st. Okay, and I saw on your list that you're looking for speakers. Are your speakers specifically about NASA programs, or, I mean, we have access to a lot of speakers, but it's about astronomy stuff.
Yeah, and I think in the past we did have some from here. We tend to have the speaker. We tend to have the speakers related on the subject that they work on it. So mostly we got spacesuit. They work a lot. We got some to talk the morphology of Mars. We have, of course, propulsion systems and eclipse systems, and so we do have speakers. But yeah, if they're related with the mission to Mars, anything you can think of, will be welcome. Yeah. You have space laws speaker, and
have you had speakers from the LPI?
I think in the past we did. And our director of education is, I used to organize it a long time ago, and now I ended off to the director of education. So I don't know if he has any contact right now, but I can put you guys in contact with him.
Well, you'd talk to Andy or Hart right here, but yeah, there's a lot of expertise here at the LPI specifically about Mars.
Yeah, absolutely. If you are interested, just approach me and I'll get you contact with our director of education, and he can set up for a speaker session. It's just down the road, so you can walk there probably.
What is your deadline for host families?
So the sooner the better. We will have to start to make decisions pretty soon. And typically, one of the things that we were forced several years to do is to ask the host family that we typically give 2 students for each family. And we try to keep it one English native speaker, one not English native speaker, so they can help each other in the family. It seems to work much better for the students, and works better also for the host families itself. When we come to these situations where now we're short of family, we start to ask the host family already committed if they can take more students. So we are getting closer to that point to resolve the situation, because we have to allocate those students. The students have, they have their tickets, mostly have visa process. Actually, just today I got a bad news from India. They got denied the visa, and we have to work something out for this guy, like we did a couple of years ago, George. But yeah, so typically we communicate the assignment sometimes in June, like the half part of June. So typically a month maximum, we'll have to have all the host family assigned. Yeah, and I'm here too today too. So if you any question you might have on commitment, I'll be happy to answer. I mean, typically, really, it's not. It's I've been hosting too, so it's a fun thing to do. It's great what those and those are the selection of the students is very strict. We have point of contact, so we're not inviting anyone. I mean, anyone can apply, but we're really making sure that the students we get here are very good students. We really never had a problem over 27 years, so. We really take a lot of effort in the selection process. Have a question? All right, thank you. Appreciate the time.
Okay, Francesco, I do have one more question. How many students stay with each family? Two?
Two, yeah.
Two, got it. All right, thank you. Okay, next up we have David with Star Party News. And David, we got a reprieve from Andy. We can be 10 minutes late, so don't worry. We're okay.
Slide some pictures, Doug. Feel free to chime in here. All right, Star Party News, April 16th to 20th. JSCS went to the X-Bar Ranch, and on April 28th, Friday, I wasn't there because of a work-related issue. Club had a outreach event at the Hack Winery. May 13th, Star Party. Again, this has now been postponed. I will get that to a week from tonight. I will get that flipped over onto the website. May 14th through the 20th is TSP. It's just around the corner. We've got two upcoming again at the winery. Reaching out into September, 8th through the 16th, it's Okie-Tech, El Dorado, 9th through 14th, which I believe that's also back at X-Bar, isn't it? And then 12 through 15 is Fort McCabbett. We've got a stargazing event planned with the Evelyn and Meador Library sometime in the fall. We want to try to work out those dates. Those are still under discussion. X-Bar Ranch, I forget who did these, mostly Reed's picture. Cute little flower, but you guys getting set up out here where it's nice and.
That's Al's setup. These are Reed's.
Okay, I got you. And then which one's yours, Doug?
That one there.
This one? The beautiful one? Okay, yeah. With a little enclosure. Yeah, I see that. Okay. But you didn't take pictures of the tents or anything where you guys were staying?
Oh, we slept in beautiful luxury.
Ah, okay. So here's the gang that went to the X-Bar. Thank you for adding that. And then April 28th, Hack Winery, thanks to Chris, Reed, Bob, and Leslie. And then Chris told me there was somebody who did not identify themselves. Any word on that, Chris? You didn't? Nothing? Okay. 3 scopes, 1 pair of binoculars, roughly 75 in attendance. It started clear, but some of us found out at the George. I'm sorry, as I found out when I was in Galveston, it got socked in by 8 o'clock, and by 9 o'clock, it was thunder showers. Venus, Sun, was obviously Sun with a solar scope, Moon are the primary targets. So Reed, and then there's Chris, and the Hack made every effort to try to feed us. And as Aaron goes, woo, I just created a 24-hour period of alternating lightness and darkness on Earth. What are you going to do now? Call it a day.
Lots of comics tonight. That's good. Yeah, you guys like that, don't you? Okay, door prizes. Look for your door prize ticket. And thank you, Hart, for being our door prize guys and door guy. Thank you. Door man, not the door prize guy. Okay. First one. 897. Nine seven. 86. Oh, is it? Is it you? That's hilarious. All right, get on over here. Woo-hoo, you came to the right place, man. Okay, thanks to Craig up there. There's Craig. He brought some books. We got the Galaxy and the Solar System book. Or we have, thanks to David, we have a moon map. You can go out and look at the moon, know where all the craters are. Or if you're a fan of the Starliner mouse pad, or thanks to Rick, we also have, this is really cool, we have a DVD of the, tell us Rick, the lunar, the 16 millimeter from the, yes.
And what we did was
Yeah.
All right.
What do you want? You gonna do that?
We did this presentation.
Okay, there you go. Excellent. You can keep that. We won't even check it. I love that. Now, if Aaron gets the next one, we're in business here. All right, 889. 9. Oh, another presenter. All right. Get over here, Austin. The galaxy and the solar system. Oh, wait a minute. I got another one to show you. Don't worry. You don't have to take this if you don't want it. It says, I'm an astronomer. What's your superpower? It's what you put. It's a decal for your car. You don't have to take that if you don't want it. Or a book, Galaxy and the Solar System. CST 100 mouse pad, moon map. Moon map. All right. Excellent. All right. One more. All righty. 868. Is that you, Andrew? Is it? Come on, man. All right, Andrew. Okay, I'm an astronomer. What's your superpower? Galaxy in the solar system or a CST 100 mouse pad? Pick the book. All right, excellent. Okay. Next month, we're going to do something a little different. We normally have a really great speaker like Aaron, but next month, we're going to have a bunch of JSCAS members. We're going to do a bunch of short presentations. We're going to have one, Mark's going to do one on near-Earth asteroids. Leslie, there's Leslie over there. She's going to do one about cowboys and astronomy. Jerry, where's Jerry? So you can get a look at these guys and figure out if you want to come or not. There's Jerry. He's going to do one on Vera Rubin. Brandon, who's not here, is going to do on the HR diagram. And Justin, there's Justin. He's going to do one on weather science and amateur astronomers. So it's going to be cool. Going to do a series of presentations by our own members. So hope you can come. Thank you very much for coming tonight. See you at Mod Pizza right after the meeting. Thank you.